So, brief introduction about myself. I am Zara Laila. I'm a blockchain research analyst with the Research and Development Division at the Information Technology Protective Security Services, Brunei's leading cybersecurity solution provider. I'm also a member of Cybersecurity Brunei, the National Cybersecurity Agency of Brunei Darussalam. I hold various blockchain-focused certification and have an academic background in information security. I have published a paper proposing the use of blockchain technology for the authentication of academic credentials in Brunei Darussalam when I completed my master's, and recently delivered a segment on blockchain technology on RTB Serampai Pagi and also the International Women's Day with Women Tech Makers Brunei. So today's session, I'm joined by Haziq Hamzani and Safwan Ahman, who are both our developers, blockchain developers for our ongoing research and development project pertaining to blockchain. You may ask questions throughout the session and they will happily answer your questions. Should there be any topic of discussion you would like to have, please highlight that in the questions and we can address that at the end. So let's first talk about blockchain technology. So blockchain technology is a distributed ledger of immutable digital records shared on a participating node on a peer-to-peer network based on a consensus verification mechanism. All the nodes on the blockchain will have a copy of the same ledger. So the technology was actually initially developed based on a peer-to-peer electronic cash system by Satoshi Nakamoto in 2008. It eventually emerged as Blockchain 1.0, eliminating the need for intermediaries when transacting payments on a peer-to-peer network. The technology eventually progressed towards Blockchain 2.0, utilizing smart contract ledgers, with the rise of Ethereum to create decentralized applications. So Blockchain 3.0, at its maturity, provides a solution beyond financial domains to enhance security and innovative use cases, which include decentralized digital identity management. Blockchain 4.0 prepares itself for the application of the Industrial Revolution 4.0 for industrial use cases with the integration with IoT and smart devices, also focusing on Web3 and the metaverse applications. So the blockchains are generally classified into three: public blockchains, private blockchains, and the consortium blockchains. There are also hybrid blockchains. So the public blockchain allows for anyone to join the network and participate in the consensus process. So this is what is used by blockchains such as Ethereum and Bitcoin. Private blockchains, on the other hand, only permits authorized nodes to participate in the network through an invitation. The consortium blockchain is a combination of both a public and private blockchain. It may also be called as a public permission blockchain, which is what our research and development team are also looking into. So the first type of blockchain emerged as public blockchain, which allows anyone to read, write, and contribute to a consensus. But this is not ideal for most companies because they are dealing with a lot of sensitive information. So that's why the private blockchain emerged. This caters, although that it defeats the true purpose of creating a fully decentralized network. Certain organizations would like to ensure that the data is kept within their organization or within their network, which also may be done remotely over different countries or locations. So I need to explain exactly how does a transaction go on a blockchain. This can be a Bitcoin transaction, an NFT transaction, or verifiable credential transaction. So the first thing that would have to happen is the user will first have to initiate a transaction, request a transaction. A block representing the transaction will then be created, but this block doesn't necessarily just contain one transaction. It can contain multiple transactions. It has to undergo an algorithm process that will allow it to be transacted together. according to its speed, its size, and the number of data it has. So the next one would be the block would have to be broadcasted to all of the nodes in the network. So there would be an initiating node. Then the node would have to broadcast that same data to all the nodes on the network. All the nodes on the network will validate the block through a consensus mechanism. So I'll explain more about consensus mechanism later on. Once they have reached an agreement, all the nodes on the network has reached an agreement, the block is then added onto the blockchain and the transaction is therefore completed. So once a block is added into the blockchain, it can no longer be changed or removed. So there are a few security aspects of blockchain that are always being brought up. Like that's the reason why people implement blockchain in the first place, to enhance the security of existing infrastructure or databases. So the first would be it's decentralized, meaning there's no single point of authority to manage this, ensuring that there is no room for corruption. So next is immutability. It means that once a transaction is added onto a blockchain, it cannot be changed or removed even maliciously. Asymmetric cryptography involves public key encryption to ensure that the data stored is not readable to the human eye and can only be decrypted through the verifiable means. Next is distributed ledger. So the same ledger of transactions containing all these transactions will be copied across all the nodes in the network. Can we imagine having probably 1 million nodes, or let's say Ethereum has about 8,200 nodes. Imagine modifying just one node itself. It's hacking one node and maliciously modifying it is difficult. So can you imagine modifying 51% of the node to fully penetrate the blockchain itself? So that is difficult in itself. So next is the consensus mechanism. So as I mentioned earlier, an agreement has to be met to ensure that the data added onto the blockchain has not been is indeed authentic. It's not modified. It's not malicious before the whole node broadcasts and stores the data. Next is hash Merkle tree structure. So I'll be explaining this further on. This is something that's very important to understand when it comes to blockchain. So here's an example of immutability. So when a new transaction is added into the blockchain, the transaction becomes immutable. As I mentioned, it cannot be modified or removed. Here, I have one example. As you can see from block 1, 2, 3, 4, and 5, it already stores, each block stores the current hash, the previous hash of the block, and the data itself. The data can actually be other things, but I've simplified here in this diagram for everyone. So the second block would also have a copy of the previous hash, which, as you can see, which is in block 1, A1, B3. And then its current hash is based on the combination of its previous hash and the current data. And you can see in block 3, the current hash is based on the previous hash BD3F, which was from block 2, and the current data, which is Awang Abu. So this goes on up to block 4 and block 5. So what happens if we modify just one data in the blockchain at any point of time? And this, let's say a node has been maliciously tampered with. So Awang Abu in block 3 is changed to Awang Ali. As you can see, the previous hash remains the same. Tapi the current hash, it changes because like small changes can, even if it's just like 2 letters or 1 letters, it can change the current hash of the block. I will also explain this further later on. So if you change one hash, the hash of the current block, it will also change the blocks, the preceding blocks after that. So this allows for the identification of a malicious attack immediately. So next is asymmetric cryptography. People who specialize in cybersecurity already know this. So blockchain applies security computational technologies such as digital signatures based on asymmetric cryptography implemented through complex mathematical algorithms utilizing public and private keys. So this figure demonstrates the process of a sender digitally signing a transaction on the blockchain. The sender's data will be hashed using a cryptographic hash function and eventually be encrypted with the sender's private key to create a digitally signed data to be sent to the receiver. The receiver then receives the hash data that has been decrypted with the sender's public key. If the hash value, as you can see here, signature is valid if the hash value matches. So this is how it works on the blockchain. No actual data on the, it depends on the type of blockchain as well, but no one would actually want to store confidential data on the blockchain. So no actual data itself is stored on the blockchain. It will only cross-reference with the hash data. So if the hash data matches, then it is surely it is not maliciously modified, not even by one letter or by one space or character. So this is an important feature of blockchain because although we do have our centralized database, we still have to ensure that our transactions have not been tampered with. So we verify it with the blockchain. So moving on to, okay, before we move on to this, Iswana, can you launch the first poll? So we would like to invite everyone to answer this first question because I would like to understand everyone's objective in joining this webinar. Okay, so I understand most of everyone has a interest in cryptocurrencies and NFTs, but for those who are genuinely interested, I believe it's for the purpose of research and development as well. Okay, thank you, Iswana. Iswana, can you also launch the second poll? So which type of consensus mechanism does Bitcoin and Ethereum use for this is open to the cryptocurrency experts as well? Okay, so most of everyone, as you can see here, do not know the answer to that. But those who answered proof of work, you are correct. That's okay, everyone. You still get a chance to win the lucky draw. So let's move on to consensus mechanism. So as I mentioned earlier, the consensus mechanism is a security feature as well. It consists of algorithms to determine how the agreement is reached while impacting the computational cost, security, and efficiency. As you can see here under proof of work, we have examples such as Bitcoin and Ethereum. So proof of work does use high energy consumption because they have to undergo a heavy computational process, which requires them to have what we call a mining rig, very high-end computers to solve these complex algorithms. This is why it's so secure, but at the same time, it's also very harmful for the environment. If you see, it can only accommodate about less than 100 transactions per second, and its fault tolerance rate is 49%, meaning if you penetrate 51% of the network, it basically modifies all the data there on that blockchain. The response time as well takes about 10 minutes. But for proof of stake, which is what Ethereum 2.0 is trying to transition to at the moment, it uses low energy consumption because the process of adding new blocks onto the blockchain is fairly different. So what makes it different? Unlike proof of work, which requires high computing power to solve complex algorithms, proof of stake requires a node to deposit a monetary amount In this case, if in the case of if Ethereum were to transition fully to proof of stake, it would be ethers. So the higher the stake you have in that blockchain, the higher your chances are of mining the next blocks. Why is it important that they mine the block? Because they get rewarded. So if I were to, so how is this a security feature? Unlike proof of work, because the proof of stake, you have a chance of losing that deposit that you have made just to mine that block if you are having malicious intent. So what about delegated proof of stakes? Because proof of stake, once they have the highest stake, they can delegate that specific transaction to a different node. So that uses very low energy consumption as well. So I've highlighted practical Byzantine fault tolerance. This is personally our favorite. It uses very low energy consumption. We use it with Hyperledger Indy. The response time is faster as compared to proof of work and proof of stake. It can accommodate more transactions at a time. It undergoes an algorithm process that ensures that it is secure. So in this case, it would be about 77%, 33%. Okay. For anyone who wants to know more about practical Byzantine fault tolerance, you can always reach out to us. We'd be happy to share more because it's something our research and development team are fairly interested in. So next is hashing. Before I move on to hash Merkle tree structure, I mentioned hashing earlier. So hashing is an irreversible one-way encryption function used in blockchain to convert data into a fixed length value. So hashing is also an encryption method. Unlike asymmetric encryption that I mentioned earlier, it doesn't require a key and you cannot decrypt it. So once you convert from one thing to another, it stays that way. Here we have an example because I've mentioned in the previous slides that even two letters can make a significant change in the hash data. An example here is what is most commonly used in blockchain is SHA-256. SHA-256 is a pattern cryptographic hash function that outputs a value that is 256 bits long. So as you can see the data between Awang Abu and Awang Ali, you can see that the hash data is very much different. This is not even readable to the human eye. You would have to probably, for me, the only way for me to actually find out what this data means is to I don't know, going through a library, probably like tukar nama tu one by one, then baru match the hash data to see if it matches. So that's still pretty much impossible. It is possible, but difficult to do. So this is another important feature of blockchain. Next, hash Merkle tree structure. So the Merkle tree structure is a structure that maintains and organizes multiple transactions to produce one hash for each block. As you can see here in block 2, there's the Merkle root. That is what will be stored in the blockchain, in addition to the previous hash and also stored in the current hash. Tadi, the only example I gave was data was like Awang Ali, Awang Abu, tapi it's actually not just that. One block will most likely contain more than one transaction. But so it's such a shame to just store one data per block. So if any changes are made to any one of the datum in the structure, anywhere from transaction A, hash A, going up, it will modify the final outcome generated from the hash data, which will eventually be included in the blockchain. Hold on, everyone. Can you see my cursor on the screen? Okay, so here we have transaction A, transaction B, transaction C, and transaction D at the bottom. So these transactions will be hashed first. It will produce a hash of A, then hash of B, hash of C, and hash of D. So once you produce that hash is further combined again. It will produce a hash combination of hash A plus hash B and hash C plus hash D. Then that will again be hash all combined. So there's no way for any data in the blockchain to be basically readable to the human eye because this data is already hashed. Tapi imagine like I change the transaction of hash B. I'm a hacker lah. Aku tukar hash B punya. Instead of RM1, aku tukar jadi RM5. Okay, let's make it 1,000,000 lah. So the hash B it will already change. And I've already mentioned previously, like in this slide that even one small data change, it will change the overall hash data. So once I hash that again, it will change more significantly. And it's not just these transactions, but it won't be just 4 transactions. There will be more. So it's difficult to pinpoint exactly where. And that data will eventually be stored in the blockchain. That is what makes it secure. Amazing kan blockchain ato. So there are many use cases for this technology. There's e-commerce, digital currency, record keeping, security, smart contracts. So I would like to give an example for verifiable credentials. This is one of our highlights, our favorite thing to talk about here in ITPSS in our research and development. So verifiable credentials, can you imagine if right now we're using our IC and let's say it's stored in a centralized database. And then I, as an employee within the community, within their system, have privileges to modify the data maliciously. Tapi it will surely change the centralized database, and I would be able to change my name from Zara Laila to maybe Datin Zara Laila. So that's not right. So what we have to do is introduce a solution called verifiable credentials. We need to be able to verify that that data is indeed correct and not maliciously modified. So the first thing to do would be to introduce this to integrate it with the blockchain, store the correct data on the blockchain, and once that data, my real name Zara Laila is on the blockchain, I can share that same data to various organizations, or I know apply a banka, apply for a loan, open a bank account. Then they will be able to verify my data with the blockchain. It won't show it's Datin Zara Laila. If I ever try to even go to the bank and it says Datin Zara Laila, I'm pretty sure that it will show that it's not verifiable. So this acts as a trust mediated intermediary between us and third-party organizations and also the issuer. So I'm pretty sure another good example would be, let me see. Okay, let's talk about intellectual property. This is actually also pertaining to NFTs for those who are interested. So with NFTs, they utilize smart contracts. Although it's intellectual property is more towards record keeping here, it's because smart contracts, the ones associated with NFTs are also associated with cryptocurrencies, which everyone has to be careful with. So NFTs basically allows people to store their, not really store, to deploy their digital asset, such as an art, a digital art, music, videos, onto the blockchain with details of the ownership rights. And this will undergo a smart contract. So once you decide to sell it for a certain amount, that right of ownership is automatically transferred. That's why it's using smart contracts. Smart contracts basically listen to what we program it to do, which is what NFTs are built upon. And why do NFTs implement blockchain anyway? Because, like, as we've already talked about this, it's because of security. We want to ensure that it is owned by who it's meant to own. So I've heard cases of how, I've read news articles of how this person yet bangun in the middle of the night, then he sold one of his precious NFT. What was it, the monkey? So he sold his precious NFT for probably kekurangan a few zeros lah pas saya baru bangun, tapi it's already sold. There's nothing they can do about that. Pasalnya andang the smart contract sudah execute that. Sudah execute the buyer and the buyer and seller punya agreement. So there's no way to tamper with that. Pasalnya andang sudah the blockchain has stored that smart contract and the transaction itself. So it's important to be careful lah. Kalau boleh jangan tah jual or bali NFT masa baru bangun tidur. So next, So as I mentioned earlier, I'm part of the research and development division. I'm accompanied by Hazik Hamzani and Safwan, our blockchain developers here. We are led by our talented blockchain expert and head of research development, Tuan Fahmi Osman. So we're actually working on verifiable credentials, and we're very keen to get this out on the Brunei market. So where we currently stand right now is that we're in our prototyping phase. We will be showcasing our first development to the public on June, sometime in June during the MYCE. So we're hoping that the public will be able to engage with us on this and become beta testers. Izwana, can you launch the last poll or any poll? So okay, let's before we go on to the last poll. So do all blockchains require high computing power and are also harmful for the environment? Yes, it's false. It is not all blockchains are harmful for the environment. As I mentioned earlier, it depends on the consensus mechanism and also how they've implemented their blockchain as well. So I'm glad to see that a lot of people understand this now, because we've gotten inquiries regarding this, like, why are we promoting blockchain when it's harmful for the environment? No, not all NFTs are harmful for the environment. Not all cryptocurrencies are harmful for the environment, and not all blockchains are harmful for the environment. So the next poll is Wana. So do all blockchains implement smart contract? Okay, the answer is actually no. Not all blockchains implement smart contracts, because as I mentioned, the first blockchain ever implemented was the blockchain 1.0, which was used for peer-to-peer digital payments, also known as cryptocurrency. So these didn't utilize smart contracts. That only came later on with Ethereum. So we have to understand why people are for the technologists out there now, not as a foreign exchange investor. Let's talk about why cryptocurrencies are so popular. They're actually because they're secure. The way that it's being implemented is because it uses blockchain technology. It stores a ledger of transaction, unlike current most processes where we go to a bank, they store our data, they store our transaction. We have this amount in the bank, and but we expect the bank to govern that process before it goes. Let's say if I want to transfer money from one bank to another, I would have to wait for the approval of one bank and another bank to accept that transaction, and they have to check if this balance ada kan ada. Tapi with blockchain technology, it is able to compute by checking the transactions from the very beginning to ensure that without the need for intermediaries such as a bank, they just check amongst the nodes themselves that are transacting on the blockchain network to verify with the blockchain that, yeah, this person has this amount, and yes, this person can transfer to this person at any place in the world without the need for intermediaries. So Iswana, can we have the last poll? So as I mentioned, we have our verifiable credential R&D project. We would like to see if there are people interested in becoming beta testers. for a verifiable credential. Basically, this will allow you to store information such as your IC in your mobile devices and be verified with the blockchain. So we're very keen on seeing how the public would react to this kind of information na, and hope that it will be accepted widely by the public. Okay, yes. So we'll try to collect your information after this webinar. So during the International Women's Day, someone brought up the blockchain trilemma. So the perfect blockchain boasts three elements: security, decentralization, and scalability. But finding a balance between the three is difficult and presents a problem referred to as the blockchain trilemma. Blockchains are often forced to make trade-offs that prevent them from achieving all three aspects. So I would like to use cybersecurity as an example. When you make a system too secure, it becomes unusable. Imagine if I've implemented a So first we have our username and password. Then we have our one-time password sent over the phone. Then we also have our biometric information. And then so this process is such a hassle to many. We have to find the right balance between security and also usability. So the same thing goes with blockchain. We have to find the right balance because if you make it too secure, you compromise on decentralization and scalability. Like let's say if when we say security, maybe we add a centralized authority to manage the blockchain just to maintain its security. So this becomes an issue. Or so decentralization creates a block means that creating a block in a system that does not rely on a central point of control. Scalability, the ability for blockchain system to handle an increasing growing amount of transactions. Because blockchains are becoming so popular, especially the one used by Bitcoin and Ethereum, they especially Ethereum now, because they're using smart contracts. So they have an issue with scalability, meaning that the blockchain data is growing and all these data are being stored in different nodes. How people overcome, how many developers and researchers overcome this is by sharding. Let me explain that further. So basically, sharding is the process by which they break up larger blockchains into smaller ones so that the nodes would be able to manage less transactions on the blockchain. But this itself has its security trade-offs lah. So we have to be able to find the right balance between all this. Do we want to make it too secure, highly scalable, or decentralized? So scalability and decentralization are often what's being trade-off to maintain security, but security tends to be compromised by any shifts on a network that offer scalability. So projects either choose to focus on two or three to work or on finding a solution to tackle this trilemma, or innovative ideas such as sharding, I've mentioned earlier, are being implemented. So because it's still new technology, okay, Brunei has yet to implement this, tapi there are room for research opportunities within this area, maybe for your master's or PhD. A solution to the problem could lead to greater adoption of cryptocurrency and blockchain and a widespread of use of the technology across industries in the future. So the sooner we come up with with a solution to this problem, the better it is for the world. So before we end this, I will be addressing some of the Q&A.